All right, Blue, let's dance. So if y'all remember from my lockpicking video with my physics brother, my theoretical physics brother. All right, so he's not my brother. Obviously, he has no fucking clue who I am. But at the end of it, it's the guy that I use in the. You got. I think it's. Oh boy, I can't. For some reason, I can't ever remember his name, but I always remember fucking Zach, and they're always together with each other. They're kind of friends with it. They've done videos together, so obviously they're synonymous with each other. I think it's Andrew. I'm not positive about that, but like I said, when it comes to, there doesn't need to be a name when it comes to the guy in which I am thinking of, and in which and it's horrible because you never give credit, but obviously that'll get passed on through. But he was going through tensor calculus, and every 10 seconds he was saying mu, the muon, the mu, the what other concepts are, lambda, right? You're chasing the rabbit and stuff like that. So what immediately kind of rings off to me in the theory is we do have some problems with this. It doesn't seem like these things are quite relative, but they are. The muon. And that's to say, any piece of equipment has the ability to express this glitch. In Pokemon Go, and you can kind of tell through the theoretical, older understanding of what this is that. Yeah, I got some glare going on. That this is not a new concept in physics when she's talking about thousands or hundreds of years, centuries of information on the standard model. She's talking about fix this glare here. All right, she's talking about it in a way that she's been there, obviously, or close enough to it, probably more familiar with the actual people, places, and conceptual models than I am. Yeah, I wish I could get that glare to come off. Well, at any rate, but basically, as I was picking that lock, you would see something that is not necessarily considered a particle. And what I mean by that is the pick is a particle, the lock is a particle, the pins are a particle. They have brass. Most of that internal work is brass inside of the pick or inside of the lock, but they're disconnected. And that's a glitch. It's its own particle without really being anything. Obviously, there's air inside of there, but very conducive to the environment and in which that air is next to, or gravity, gravitas. Would there really be a system to say, well, that's the glitch you got to catch? That's that Pokemon you got to get in the ball, because it's a really hard quantifiable system, a quanta, to really be able to understand. And so it's like feeds and speeds, as an ex Sawyer and as a ground guy and stuff like that, the stuff that I do, you often find this glitch. It's that management glitch, especially in the stone mill floor. There's not really a feeds and speeds in which you can really dial this into. It's more of an environmental observation that says, because we occupy this, in theory, repetition. I mean, I'm not going to say it's going to be one of those things that immediately rings off to new people. But the longer you stay exposed to a situation, you're going to find a lot of glitches. You're going to find a lot of. And go ahead, let it out. Write it down. That's a mu. Now, you know what it is, but can you contain it? Do you understand it well enough to understand its geodesics, to get in front of it, to kind of look at it like that ball or big boss that's just going to be like, one, either I have a standard model to it, there's no information, or two, what I've created in terms of engineering and studying a scientific process is its own thing. So when you get into feeds and speeds, obviously, when we're talking about this in CERN and Fermilab and things like that, we're talking about a very specific job, a very specific process. The thing travels down the pipes, it makes a collision, and we're determining those actions to be protons, neutrons, packets, whatever sub-elements of the element in itself, all of its mass, all of its weight, all of its mass, spin and charm, are being released, whatever it was, as these things collide, do not reflect themselves individually. They reflect a piece. Remember, energy is not created nor destroyed, it's transferred. So when they're talking about particles that come off of this, obviously if I have two things that are quantified as a particle and they are colliding, then the result of that collision cannot be the same material as it was. And this is through very fine precision calculations. This isn't synonymous to something that is just Fermilab, and they must maintain that. They cannot say this is the only place in the universe for it, otherwise it wouldn't be unified. It affects in the stone mill, it affects in the grocery store, it affects in every way, because as I walk through the environment, if I walk through the building door, I've essentially created a collision. Very common reciprocals, you would get used to it, but it's like the first day with a new person. And that collision is creating all kinds of elements or subparticles of human nature, right? You might know those substates, and it's something about a guy or a person or kind of the way they're behaving. Now, that doesn't make you a sociopath. That doesn't make you manic. That doesn't make you bipolar. But those are kind of those sub-reactions that they're talking about here when we're quantizing new subparticles of an event. You really can't quantify somebody to be bipolar, but you certainly know somebody can be bipolar. Very extreme in the circumstances. And so as a small reaction, you could kind of quantify that. You could kind of idealize that small reaction is pretty manic. It's pretty bipolar. It's this idea of only in very short windows of time. Well, physics, an apple's an apple until it rots, right? FMA, terminal velocity. But you wouldn't consider it, or at least you wouldn't notice this glitch as an aspect of in a day sitting on the table. There is no glitch. We know it's happening. But at the same time, without that small action happening to something observable at that point to feeds and speeds, on the saws or something like that, it's the auto drops or something like that. It's some feature that I've figured out automatically. Like I would watch that saw, or I would have somebody telling me to watch that saw. What's the observation that told me to do that? To make sure it didn't catch or kick or do something out of that manner. It's that subparticle. It's that muon. It's that glitch. And in that way, it's not really a particle. It's made up of parts of things in the stone mill and parts of people in the stone mill. They're not all truly quantified with each other. It gets a little bit more complicated when you get into numbers that have atomic weights. And that actually makes it a lot simpler. But on the turn, because the forms are basically all the same, it makes the stone mill a lot simpler. All I have to do is kind of follow a process in which that EM field of a brain scan MRI would be that mu. I know it's a particle. I know they use MRIs. I know what the effect on a brain scan terminal of the computer screen looks like. And again, so remember, we're basically doing the same thing. Collisions of electrons in the brain and in the circuitry in the central nervous system that actually says, well, what's happening here is quantifiable at the same level. For me, that's an easy understanding because not necessarily I'm so advanced with the information. You have to understand it's a one-step process that actually takes the overall study of physics that I might have a larger gauge on than other people, that this mass gap comes to come into play as that muon, right? So we're going to get going here and listen a little bit more about it, but
are not as common. There are actually a lot of them. For example, the Higgs boson. Another example is neutrinos. And then another example is the muon. And the muon is,
Okay, so real quickly, when she's mentioning the Higgs boson, Higgs was a real person. There's not really Higgs would be to say, well, this is what the Higgs boson is, right? scientific, the collisions of particles, pretty very much concise to the reactions in reality, the railgun that is where physics is going overall. Obviously, somebody caught that glitch early on in a phase, much like I do with the psychological manner, but that doesn't mean that Higgs didn't understand psychology. Oppenheimer, Valentine's rabbit, that I like to say, you will become it. After time with people in the room, you're going to see that they're not dialing in the saws correctly. You're going to see that floor techniques are out or something like that, which doesn't really seem like, well, we've all made enough money for the week. The company has made enough money, but that's not the true nature of what this is. And Higgs would say something like to that, both monetary, not necessarily because it's a money thing, but you need certain amounts because energy is not created nor destroyed. Higgs can't create the energy. We need to offset that with a Dirac's equation for an education standard. And, so when you get in there, you get good with that observation. If I were to do that, somebody's technique is out. Just because I'm walking in the stone mill and somebody else is walking in the stone mill doesn't make them the same packet. We don't necessarily have the same mass, spin, or charm, even though we are human, hydrogen number one supremo by the standard. It only gives you a set frame in which to determine that new value by scientific experiment. And so whether it be scientists that you quantify against somebody like Higgs being the standard, Higgs being that mu, that misunderstood particle or misunderstood technique or practice that went into there, that these tiny little vibrations augment something that says, I've tried everything to Kelvin this temperature to absolute zero, and no matter what you do, whether it be magnets, whether it be supercooling things, that when something passes through there, which is a causal thing about the speed of light and things with mass not being able to make it to the speed of light, here we have mass. The conversation, redshift, blue shifted, though, to the speed of light. You know that this conversation correlates to the cosmic radiation background. You understand that it correlates to things like God particles, but the steps in which to get you there to fully be able to understand those steps are basically Pokemon. Right? It's a Mew. It's in there, this click was a difference. I could put pressure, no differential, over an angle of a very specific system. They're super scientific in the example, but you can do this in the stone mill. The first example you do is to say, even though it's not scientific at all, I have no idea what I'm doing. The second time you did that, you're still recalling on the first time information. You did a thing, you would know immediately from the first time, well, there's no option from here. It is nowhere near as fast as any other option without a scientific process to be able to determine that, and that whether that be CERN or a hadron collider. Well, what is a hadron collider by other terms? A little bit more simply for us common folk that don't necessarily have the resources to create a hadron collider. And that's to say your everyday operation, whether it be a gas station, a McDonald's, you're a gatekeeper for the military. Generals rely, the generals made a job just for you, and at any time that gets segued from this, you have a massive violation in the laws of what physics are, common practices, common systems. And essentially this is that glitch you're trying to observe, negative one. When positive one or neutral, zero, I'm working the gate, somebody comes in, obviously the event of somebody coming in is positive one. They're supposed to on the ledger. Obviously on the notation, negatively, they're not supposed to. There's an event in the positive category where it's to say once that neutral system went through, it was always neutral. And so it was either always zero or it was always one. And one, even though it's in a positive form, there was only going to be calculated to a negative example. And, so it's that kind of kick when somebody goes, well, it's always positive or something is idealized as negative, that Jim is going to tell you a high-quality problem. You can't necessarily build something new unless people need new things, and that's that mu glitch. that's that particle that kind of is created into this, or it's that particle that you notice more than somebody else in the economics or sociology or even psychology of somebody. Can I take advantage of that situation in some way? That's a human thing. I wish I could tell you it was one of those things in human nature you never had to worry about anybody ever taking advantage of you. But the goal is to get the maximum out of everything that you do. And sometimes that's a realization inside the field of people that they're going to get taken advantage of. The beauty in it, though, with as many cross downsides of it, is you will learn when somebody takes advantage of you like that. There's not going to be a differential between this, well, was it a positive or was it a neutral system? You're going to immediately know that that was a negative-based system, which turns it into a positive for you. That you will never want to do that thing. And that's the kind of nature in this type of physics, or highly precise levels of, even in the stone mill, graphing and calculating the scientific method that is your specific method of your job title, or the overall index of all spectrums and what do you call them there? Sectors of that job. And, so when you go through that process, you'll find a lot of new particles or new understandings, great revelations, and apocalypses and genesises that can be created from that. A lot of shiny, a lot of profit. You're going to have a lot of hands, fingers, systems, and certainly delas de mortes, the aspects of death and being chained to gravity and how those stories go, is going to be something that is synonymous and quantifiable by those standards. To say, if I present a physics to you, the whole physics, people's names, concepts, and its aspect here, it's still zero. We can't say that that's what is going to happen, but we're planning the geodesics on that situation, in which case, at least at the moment, they're quantifying that as that mu. Or from a while ago up to today, the full understanding of that type of conceptual model can now be proven with some kind of physical results. That doesn't matter as long as you're using it in this machinery or another piece of machinery that is completely different, that is idealized the stone mill or any subcategory under CERN, that those experiments can be replicated with that result. If I quantify myself as the packet of photons, I got blood cells, I got brain cells, I got heart cells, I got fingernail cells. And essentially there's a decay differential between the purity of hydrogen, helium, and the amount of atoms individually. They're super hard to quantify. But that's that feeds and speeds. And the purer I make that state into a scientific model, the more likely I'm going to find a result that wasn't commonly understood before, and that is something that is quantifiable to a new particle or a new type of physics, a new study in the practice of electricity. How we use the cost ratios of ramping all that up to make a result, or a God particle in this case. Those experiments don't necessarily make somebody God, but if you can kind of blindfolded work your way through it, that's something that says, if that was the stone mill, I could take that person anywheres and have a super high result in terms of what the quantification of that system is. So let's carry on here.
The muon was discovered in 1936.
Yeah, it's been a while.
They were looking at the way that electrons move in a magnetic field, and then they see another particle come
how
through
stonemasons move in a stone mill.
And they're like, what the heck is that? So have you ever heard that if you've got just a uniform magnetic field and you shoot a charged particle through it, it'll curve? Have you heard of this? Okay, does it make sense? Okay, good. I'm glad I asked. What is another example of this happening? In CERN, the reason that particles go around and around is because they're charged particles and they're going around in these big magnetic fields, and it makes them curve. And then when they collide and all this stuff comes off, they're watching how they curve in a magnetic
gravity
field. That's why you see all these spiral
natural
lines
gravity.
coming
Remember,
off of the collision, because
it's hard to separate yourself from this quantization of it. If you don't know what gravity is, then you don't really have a value to it. So when they said they wanted to spin, well, there's the nature of like if I was holding this, what do you think the electron around this really looks like? I remember on Down the Rabbit Hole, What Do You Know About Quantum Physics video, which you can find on YouTube here, but they'll talk about a basketball. And the electron for that basketball basically stretches an entire city block, or New York City or something like that. But the compression of this state actually allows those elements to act in a certain way within the purity of those things. Here, I think it would be silver, nickel, something of that effect that says quantifiably the observation and the optics. Oh, it gets heavy. It gets fucking heavy in a hurry. But that's not to say it was really heavy at all. But the differential engaging that expectation from quantum physicist to Johnny down the road is that level of heaviness. You know, I have to quantify it with one statement to Einstein and some kid that has never taken science in their entire life. And by doing so, you would say that experimental place could be quantifiable to CERN, right? It's just a 1 and a 0 state that says internal housing, internal containment. I want to take advantage of forward momentum and create that into something that has spin. If the momentum of an object with right hand spin is so much forward, it's obviously going to go forward, but it's going to spin. So you have to know that distance. You have to know that measurement, which would give you, oh, well, this actually goes right or left or right, up, anti-up, V at the top, figure out the housing, but it would go right after about a foot. Well, I can't let this straight thing do with that internal momentum. I better wrap it around. And then you find out, well, it can start to turn. If I can turn it like that with something of a distance that is physical to not necessarily a solar mass, but instead something that is at the quantum level, a particle, an atom, a neutron, a proton. I don't know if they can quite separate those things from the atom, but the aspect of when you do the housing of that, the feeds and speeds, the internal containment, the lattice structure, the element you're choosing to then put it down in the pipes for internal containment. There, little, north would be perfect here, but as you go a certain distance, without fragmenting that to a massless state, that there would be a distance. And if I hit that phase oscillation correctly, then this magnet should be like that, and I will continue that spin in a forward momentum on an object. So there I can ramp up the speed, bring it around, and then interject that with some other system that does the same thing. And you could say that loop works equally. I can have two of them going at the same time, and then they'll cross, and I'll make a collision. And what I'll get from that is subparticles. Stonemasons load the saw. What am I getting? I'm getting time reviews. I'm getting cut coefficients. I'm getting all kinds of subparticles from that event. And they cannot be done without the quantization of that full particle. It's difficult when people don't study this material, but at the same time, you don't really need this material to do the job in what you're doing, nor do you need it to be able to make it to the atomos of that function. A lot of the times in here, it's one of those differentials of they should.
If a particle has a negative or a positive charge, it'll curve one way.
Am I negative right now or positive to quantum physics?
If it doesn't have a charge at all, like a neutron, it just goes straight. So you'll see those spirals, and then you'll see the straight lines. So there's these guys, and then they see another particle come through, and it has a much wider arc. Much wider means that it has more mass. So they found this particle. They're like, what is that?
Man, inversion.
Out it is just like the...
I was expecting it to do actions at a spooky distance. That means if it was more than that, well, it's not necessarily heavier. If you're shooting a 22 over a distance, if you're close enough to it, you'll actually notice this rise from the scope. But as the distance increases, that thing will hit the geodesics to that difference. And as long as it's within the range of targets, center mass of collisions, you'll get that deer. You know what I mean? It might be a little low. I didn't hit the heart, but I caught the bottom of it and clipped a lung. I'll take it. That's a reaction. And that says, well, I didn't get the result of the perfect God particle I wanted, but come to find out, that scientific method still leads to the same result, but we'll call it an additional step. The purity in which the refining process of the windage, the hunting, the scent, the smell, all subparticles means that I misvalued that situation, which means it was much heavier. If I missed the calculation by the rules of physics, it would to say +1 in the addition of that, or to say that I overestimated it and it would be -1. I overshot it or I undershot it by a differential, and it is real basic FMA physics of trebuchet.
The electrons, a lot of people call it the cousin to the electron, but it has 207 times the mass. Oh, so that's what they discovered. They discovered the muon. If you had a bunch of muons instead of electrons in your atoms, you would be way heavier. I don't know how much heavier. Okay, so the measurement that was just made
Fuck all them
was that
lambdas and mu's.
It's gonna get really tricky. You know how a top that's spinning will kind of wobble around? If the top were in space, it wouldn't do that. It would just spin. It wouldn't wobble. The reason that it's wobbling is because it's spinning in a gravitational field, and gravity is having an effect
that gravitational field was a stone mill.
Can you accept
Yeah, this
that?
would be a stone mace.
I'm good, because I don't want to go in. Similarly,
Could you
there's
be a
another
physicist
really
and foul the stone
complicated
mill?
property of particles called
Well, those
spin.
things aren't
It's not
necessary.
like the
There just
particles
may not
actually
be a
spinning, it's
position
just a
very
property.
hard to
But
get to.
when you put a
Have to
particle
do a
with
whole bunch of
magnetic
scientific
spin in a
experiments to get
magnetic
into there
field,
that safety
it'll wobble
officer and manager,
similarly.
huh?
The amount that it would wobble is something that we can predict. Say that the amount of wobble is
I
supposed
know,
to be
because I
the amount
made
it's supposed
it.
to wobble
Like I
is
wrote
called
the
the G-factor,
book.
and the theoretical number is supposed to be 2 for the muon. Now, there's something else weird that we've theorized, which is that the wobble should also be affected by something that people call quantum foam. Have you heard?
Well, the nature of something like quantum foam is, all right, so you're standing in a stone mill in the middle of the winter, and it's hot. It's hot. I mean, whether it be physically because you're running around in gear doing things, or whether just the situational nature of life is connected. Again, all those small points, it's a foam. They're a bubble. I don't really know what it is. They can expand. They can absorb into each other and become the same bubble by all of the parts that make it heat. Heat, light, and sound. When they start bitching, this is a Torino scale of nuclear fission. Right, it's just played off on very slow time scales with elements that don't have that state, but because they are all equal to 0 and 1, they become very foamy, very foggy.
The idea that there are constantly particles popping in and out of existence in the vacuum of space.
I say fog because
so
Nuke
those
and
particles
Mars.
popping in and out, when that happens, they can interact with a particle, a real particle that exists, like a muon, and then they can affect that wobble.
No,
I know that this is getting to the
what's the
point where it's like,
value
okay,
of
what is the point of
there
all
should
of
be
this?
ice in
We've
the
got
ice
quantum
caps.
foam
How do we
affecting the wobble,
release
but
it
we're
as
almost there,
fast
and we
as
have a number
possible?
for that, and it's
Bunch
like,
of bubbles.
It's close to the
Specifically
it's like
boxes or
2.00,
marshmallows.
and then there's this added correction. 23318.
Those marshmallows, one-dimensional words on two-dimensional sentences and to describe three-dimensional objects in four-dimensional space-time. Seems like bubbles on top of bubbles on tops of bubbles. To me, with bubbles everywhere, or the cosmic radiation background, or excuse me, the cosmic web.
Of the G factor, of the amount of
that would be
wobble.
that measurement, cosmic web.
Didn't match the
If the number,
so it didn't match it by,
but they don't need to.
In the last 4
We're just saying in parallel Feynman diagrams that towards foam theory to the stone mill theory, apprenticeship theories.
No, it doesn't mean that the foam is not causing it. It means that
You're
that
looking,
there's probably particles that we don't know of.
Again, reality. I didn't go out and see the cosmic web, of the universe, but I can generally assume that things will collide together, they'll get there, And in fields with magnetism, eventually something's going to happen that creates a ribbon inside of there, even though if it's not a perfectly round edge. If you get a bubble next to a bunch of bubbles, they kind of look square, right? Right, just a bunch of soapy water on there. They look generally round, but if you take a very close look at them, they have these two things pushing each other. The hexagons inside of a bee comb are more of a nature of that compression of that makes them square, or hexagons, not round. As they're building that comb, that these compressions next to each other, straight here, I have to build it along there. And so you would always end up with small voids between the bubbles if it wasn't one into the next with each other in quite a manner. So what's she talking about? I kind of can agree with, it's just a computer background or a computer output, because there's no telescope that can really observe something like a cosmic thread or a cosmic web in which all the galaxies are in, short of a voidy cluster where there's a giant differential between mass being here. Why those mass travels on those things would be magnetisms, would be electricity, would be because it's creating an electrical field in magnetic or in a space that's going to say the reaction between those things are going to act in a certain way. It creates a new state of matter, if you will. It wasn't quantifiable before. We didn't give it a number value. It doesn't have a weight. It doesn't have anything that can quantify that, or any observations that separate it in any way from any other value. So therefore, if that value was done, I could say, well, add 6 of them together, and there was obviously 6 of them being there. If I tried that there, the ratio of, well, I got that number, we hypothetically evaluated that to say the matter. They're much more likely that out there in that soil there's going to be a little silica, there's going to be some organic matter, there's going to be some things over 13 to 14 billion years worth of the evolution of the universe that is more prevalent in its observation than quantifiable on the super macro scale of then even more macro of collisions of it. Man, I can't separate a particle. I'm sure there's a few in this bottle at Advil, but to basically see the connection between those things is not very sensible to me. But on the turn of that, here we got something you probably do on the very common, your red ledger, your stock market, your scientific value, that you would say, well, what was the difference? That's a lot of work that goes into their measurements, time systems, but they're quantifying it to something in a very different field that quantifies this. And that can be a new state of matter, especially if it's massively misunderstood against the human populace. There's all kinds of paradoxes about intelligence, human intelligence, why it's quantifiable to our scale instead of anybody else's scale, because that's a common problem. And you need problems like that in mathematics to go 1 + 1 = 2. The common sense, the pattern, the variable that goes with that should be quantifiable. 3 + 3 =... Well, if you've never known that, then 6 is a new particle to you. But if you've always known that, then it's easy to say that value is. But we're quantifying that with this thing, and this thing don't make 6. And but I'm sure there's more than 3 parts in here. It would just say 2 things. And it's on that understanding of those things. Oh, you can use oxygen to create fire. With a spark, you can use just raw oxygen, the molecule by itself, separated in just its purity, but in the atmosphere, no combustion.
Know of, or forces we don't know of, because we have such a precise idea of how the wobble should change based off of known particles and how we know they pop up into existence. So
temperature.
If we measure something different,
do you believe in that? No, I don't believe in that. What are you, crazy? Seems like a temperature differential to me. see somebody passively into a situation when it was supposed to be hot. That's temperature, and it has an effect like a positive entropy.
But it's the way that we don't know more that's important.
All right, so catch you in the next one.